Hi guys, going to talk about doing simplification today and multiplication and division. So this is section 8.4, simplifying rationals, multiplying rationals, and dividing rationals. And today we're going to have to be careful with all of the simplification that we do. The order is going to be important, and so on and so forth. So as you go through these things, just make sure that you're being careful, taking your time, and then go back through these notes if you need to. All right, so the first thing we need to do is define simplest form, and when you have simplest form, okay, that is when there are no common terms or factors in both the numerator and the denominator. So you'll go through, you'll check to make sure that if there's a term in the top and a term in the bottom, that you'll simplify it. And as you'll see later, you'll also be doing the same thing, like if there's two portions to the problem. So there's a multiplication problem, you'll have a left side and a right side. If there's something in the numerator of the left and something in the numerator of the right, you're going to do it at the same time. So, all right, example 1. Write in simplest form. Okay, we're going to write x squared plus 7x plus 10 over x squared minus 3x minus 10 in simplest radical form. Or in not radical, simplest form. Sorry. All right, first thing you're going to do is you're going to factor the numerator and the denominator. So x squared plus 7x plus 10 is x plus 2x plus 5, and x squared minus 3x minus 10 is x plus 5x minus 2. So then at this point, I would go through and I would check to make sure or see what our discontinuities are from last week. Checking to, and then making sure that you write it down so x cannot equal 5 and negative 2. And then you start looking for things to cross out. So if there's a term in the top, term in the bottom, they're the same, cross those out, rewrite the leftovers, and then make sure you write your exceptions as I did here. If you guys can't tell, I'm voicing this over because I forgot to record the first time, or record my voice. So this is a voiceover of what I did. So that's simplest form. That's how you leave it. There's nothing else to do with that one. Example 2 is going to be multiplying and simplifying. So there's a little bit more to this one. So just make sure you're being careful. Yeah. All right. So the problem is, if I ever get to writing it down, x squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared minus 4x plus 3. Okay, so the first thing I would do again, and I think I'm going to show this, is factor everything. So factor the numerator, denominator both. So you can see my work here, but I do x squared plus x plus minus 6 first and get x plus 3x minus 2. X minus 5 in the denominator can't be changed. And then x squared minus 25 is x minus 5x plus 5. Hopefully remember that shortcut. And then x squared minus 4x plus 3 is x minus 3, x minus 1. And then I do my discontinuities here. So here the discontinuities would be 5, 3, and 1. All right. So listing those out. Now you're looking for things that can cross out, but they don't have to be in the same fraction. So it has to be anywhere inside that red box that I created there. If it's on the left fraction or on the right fraction, numerator, denominator, it can be crossed out. So you'll see that I have an x minus 5 on the bottom left and an x minus 5 on the top right. Those two are going to cross each other out. Apparently, I thought I was really explaining something in this first time I ever thought I did this. Wow, what a long break that is. after you crossed out the common terms, numerator, denominator, you rewrite it with everything that's left over. So x plus 3, x minus 2, x plus 5, all over x minus 3, x minus 1. I actually think, looking back on it now, I wrote this problem wrong. I think it was supposed to be x squared plus 4x plus 3 in the original problem, but oh well. And then make sure you write your discontinuities. You don't have to multiply those out. You can leave them in simplest or in factored form. That's okay. I will be checking, and it is necessary to have the discontinuities. Again, if I'm not sure how Khan Academy will work with this, so just kind of be careful that you're doing exactly what they ask, and kind of look at their problems and see what they say. I had to look again, but I won't be able to do it before I upload this video. All right, so we have a second example. This one will have a little bit more canceling out, so it'll be less left over at the end. One thing to be careful with is sometimes problems will try to trick you into thinking that factors don't actually match, like that 9 minus x down there in the bottom. When you do that, when you see something like that where they have the x to the second, it probably means they want you to somehow factor something out of that. So like the negative x, I would change that to negative x plus 9, but then take out a negative 1, which is what I'm going to do about right now, hopefully. Let's check it. Yeah, it should be negative 1 times x plus 9. So you want to try to make the x positive so that it might match up something else later, because almost all your other factors are going to be positive x's. So I showed you there how to take that negative 1 out, factor the other side, x plus 10, x minus 9, over x plus 4, x plus 10. And then your discontinuities as well. Hopefully the voiceover doesn't bother you too much. So x cannot equal 9, negative 10, and negative 4. So then start crossing things out. So it looks like I have an x plus 4 top and bottom. I have an x minus 9 top and bottom, and I have an x plus 10 top and bottom. So a lot of things are going to cancel out from both sides of this rationals. So the only thing that looks like it's going to be left is x minus 4 and negative 1 in the bottom. So, okay. You could leave it like this. I would prefer that you don't. I would prefer that you actually do your division and do negative x plus 4 as your final answer, especially if it's just a negative 1. If it's a number, maybe leave it alone, or you can maybe leave it alone. But even then, I might, like, let's say it was a 2, I would still maybe advise to do your division. But especially if it's a 1, just take that 1 out and change the signs if you need to. So that's multiplication. Pretty straightforward, pretty easy. Make sure that you're just doing both sides, and then simplifying across the entire problem. Division is honestly the same thing. Except in division, you have one more thing to check for in terms of your discontinuities, and then you're going to have to multiply by the reciprocal like we did earlier in the year with fractions, and it should not be an unfamiliar thing for you. All right, so here's your example. I'll let it write out. So I can already look at that and say, okay, 2 minus x, that's going to have to be one that's going to be changed by taking out a negative 1. So first thing again, before you do anything else, is factor everything that you can. So I'll take out the negative 1 over the 2 minus x and get x minus 2 left over. X plus 1 in the denominator, if I ever get there. Man, I must have been doing a lot of talking, or what I thought was a lot of talking in my original. Okay, divided by x plus 5, x minus 2, and then x minus 1, x plus 1. Now, this is the point where it's a little bit different than multiplication, and I'm going to I think I try to highlight some pieces here, but you look for your discontinuities here, and you say, okay, it's still the denominators of both, but that red box that I just drew, you also have to make sure that that entire thing doesn't equal 0, because notice how you're going to be taking the first fraction divided by the second fraction. If that red box equals 0, that it makes it undefined. So the highlighted piece there, you also have to set those equal to 0 as well for discontinuities. So for those two, it would be -5 and +2 would make the entire red box equal to 0, meaning you would be dividing by 0, which you know that you can't do. So there's just a couple more added discontinuities that you have to make sure of. So the x plus 1 and the x plus 1 in the left fraction is -1 as a discontinuity, +1 and -1 in the right fraction, but then also, like I said, the -5 and the +2 that you have to make sure that you're checking for. So then you go, and after that, you rewrite the original, or the one on the left, but then the one on the right, you now do the reciprocal and you multiply by it. So notice how I'm going to write this one upside down, or not upside down, but flipped. So x minus 1, x plus 1 over x plus 5, x minus 2. And now we're just directly back to the problems from up above. Obviously, just making sure you keep your discontinuities the same as what we had from the division problem. Start canceling things out. The x plus 1s looks like the x minus 2s, and so on. And again, for me, always make sure you're writing your discontinuities. Like I said, I'm not sure what Khan Academy is going to make you do, so just be careful with that. All right, and this is going to be the last example. I just added this one in because I used different variables, and it also has a different kind of factoring in it that wasn't practiced in the above problems. So just kind of be aware of that. It has B's in it, so I'll let you guys write it down. Okay, so like I said, first thing, factor, always. This is just a GCF factoring on the top left, the 2b squared minus 12b. They both have a 2 and they both have a b, so I just took that out. Leftovers was b minus 6, and that's the only factor there was. And then you do your discontinuities. Again, remember, there's 3 spots in divisions, both denominators and the numerator of the divisor. So the b plus 6 there on top also has to be checked. So be -5 and -6. Cross things out, or actually, just kidding. Retract that. Rewrite the problem as a multiplication of the reciprocal, and then cross things out. The b plus 5s cancel, which leaves 2b and 2b, and then b minus 6 on top, and then b plus 6 in the bottom. And that's all the farther you would have to go. And that would be it. All right. If you guys have any questions, make sure you ask. Thanks, guys.